Alright, so we're going to continue with lesson 2.2, and we're going to talk about normal distributions. So with this, we're dealing with Marty making it back to the future. So, as it says here, after accelerating for 20 seconds, a Delorean sports car has a wide range of speeds that it can achieve, depending upon traction. The distribution of speed follows an approximately normal distribution with a mean of 80 and a standard deviation of 7.7. So, if they give us that information right off the bat, you should know, since it says normal distribution. Scroll up a little bit here so we can get this. So if it says normal distribution right off the bat, we know we're going to get a normal curve here, a bell-shaped curve. Our mean of 80 and our standard deviation of 7.7. Alright, well, if we have that, the next thing we need to do after we draw this normal distribution graph is actually label it. Again, classified as normal, it's an N. And then in parentheses, we put our mean and our standard deviation. Our mean is 80. Our standard deviation is 7.7. So again, that's your mean and your standard deviation. So that's your mu, this lowercase sigma for standard deviation. Alright. Now let's talk about this a little bit, because it wants us to label the appropriate values of the distribution. Well, they said that the actual mean value is 80. So we know that 80 should go right here in the middle for our mean value. Now they've already notated where one standard deviation is, negative one standard deviation, and so forth. So, for one standard deviation above the mean, we're going to add 7.7. The standard deviation was 7.7, so we're going to add. So we're going to get 87.7. 87.7. And two standard deviations, we're going to add another 7.7. So 95.4. And add the third one, we should get 103.1. Now going in the opposite direction. So if we subtract one standard deviation from the mean, we should get 72.3. We subtract another standard deviation from that, we should get 64.6. And for subtracting 3 standard deviations from 80, that should end up with 56.9. Okay, so now let's talk about, again, the percentages that between each of these standard deviations and what they contain. So hopefully you guys remember, but we talked about between negative 1 standard deviation to positive 1 standard deviation. So 1 standard deviation away from the mean comprises of 68% of the data should fall between 1 standard deviation of the mean. So plus and minus 1 standard deviation of the mean. So go for 2 standard deviations. If we go from minus 2 standard deviations to positive 2 standard deviations, that accounts for 95% of the data. And then if we go all the way from negative 3 standard deviations to positive 3 standard deviations, that accounts for 99.7%. So, you're asking, well, Mr. Elliott, that's not all 100%. Correct. The tails on each side that you can barely see in these, because it's drawn a lot more accurate than how I draw it, is very close to the axis. So it only accounts for 0.3%. So we have 0.15% on the upper tail and 0.15% on the lower tail. So where that gives us all 100% then. Now let's talk about as well about the sections in between the mean and positive one standard deviation. So from the mean to positive one standard deviation is 34% because we're just taking 68 and dividing by 2. So if we're doing that, we're just taking 68% divided by 2, and that gives us 34, right? So therefore we have 34 on both sides. So now we know we got 68, but we got to get up to 95. Well, let's do that. So if we took 95 minus 68, this is 27, but that's accounting for both sides. We need to divide by 2. And that should give us, oh goodness, I hate when it does that. So 27 divided by 2, Control Enter. Oh, if my pen will work for me today. And it's still not doing it. Oh my goodness. What is going on? It's a conspiracy. 27 divided by 2. Control Enter. There we go. That's the number I wanted. 13.5. So we know now that from one standard deviation to two standard deviation, there's 13.5%. 13.5%. And then if we take, we know we got to go from 95 to 99.7. So we should take 99.7 minus 95, and that gives us 4.7. Now we're going to divide that by 2, and we should get 2.35. So between 2 and 3 standard deviations is 2.35%, and over here is 2.35% between -2 and -3. Okay, so now that we have all of the percentages figured out and labeled, now we can go ahead and answer question number 2. So what percentage of the runs will give the Delorean a speed greater than 87.7 miles per hour? So again, I'll erase the color there. So speed greater than 87.7. So in other words, we're wanting to know from one standard deviation above, right? Well, we can do a couple things here, right? We know it's one standard deviation, so one standard deviation on either side, as we said right here, is 68%. So we can simply say 100 minus 68, which should give us 32. Now that's 32% for both sides here, right? Because that's just 68, that's just this middle section. That's just this middle section between -1 standard deviation and +1. So we have 32 that we need to divide by 2, which would give us 16%. Now, you can do it that way, or you can understand that if you know these percentages off the top of your head, do you really need to do all the subtraction from 100? No, let's just add up what's above the one standard deviation. We know from 1 to 2 takes 13.5. We know from 2 to 3 is 2.35. And we know that from 3 to infinity is 0.15, which that gives us 16% as well. So either way you can calculate that. I just want to show you both ways. Alright, so what percent of the runs will give the DeLorean a speed between 64.6 and 87.7? Well, we know with that we're going from, use a green here on this one, so we're going from 64.6 to 87.7. So I'm going to underline these so we know what's green is going with that one. So if we're going to do that, we know for sure we're doing -1 standard deviation to 1 standard deviation. We know we've got 68% of the data right there. So we have 68, and then we also have from 1 standard deviation to the second standard deviation. So we're going to add 13.5. In which case we should get 81.5%. So what percentage of the runs will the DeLorean will give the DeLorean a speed between 64.6 and 87.7 miles per hour? 81.5% of the runs. Okay, so what percentage of the runs will give the DeLorean a speed less than 64.6? Okay, so 64.6. What percentage of the runs less than that? Well, you can do this one of two ways. We know that's 2 standard deviations away. So just like we did on number 2, you can simply say, we know since 64.6 is at -2 standard deviations, we could take 100 and subtract 95 because that's the amount that is between 2 standard deviations, so therefore that would give us our 5%, right? But then we would want to divide that 5% by 2, which would give us our 2.5. However, if you know that you have 2.35, if you know you have 2.35 and 0.15 that are below, in other words, less than 64.6, well then you can simply say 2.35 plus 0.15, and look at that, that still gives you 2.5% as well. Okay. Just showing you, don't have to do both ways. I'm just showing you that that is how it can be calculated. If you can already get those percentages marked off in your head and you know what is what, it makes it a lot easier. Number 5, what percentage of the runs will give the DeLorean a speed less than 68.45? Whoa, 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 is that a number in our graph here? Is that 68.45 in our graph? No. It's not. 68.45. 68.45 is sitting, let me get a different color here so we can mark it. 68.45 is going to be somewhere in here, right? Okay. So we need to find what you guys should remember is called a z-score for that guy. So we can calculate this because we want to know less than. It's another key word that you need to understand, less than. So let's first find our z-score. So our z-score is going to be your value minus your mean over your standard deviation. Okay, which is the same thing as saying your x minus your x bar over, you can say the sigma as well in this case, So that would give us, if we were to do that, we'd have 68.45 minus our mean of 80, all over the standard deviation of 7.7. Well, if we do that, so we have 68.45 minus 80, that's all divided by 7.7. We should get negative 1.5. So negative 1.5. So in other words, our z-score, if this is 1 standard deviation away right here, and then 2, and it's just like where I drew it, it's like 1.5, right? So it is negative 1.5 standard deviations away from the mean. So how do we calculate that then now? Well, we have to do a little something special. Easiest way, since you guys don't have all these fancy calculators just yet, some of you may have them, and I'll show you both ways. So if you have the calculator, you can simply go here and click on Menu, Statistics, Distribution. So Menu 6.5, and then Normal CDF. So Menu 652. Now, lower bound is talking about all the way to negative infinity. So the lower bound's to the left, right? So we're wanting to find, it said, we're wanting to find the values that are less than 68.45. Well, we know that our z-score is negative 1.5. So we want to find from negative 1.5 all the way to negative infinity. So we're going to leave our lower bound as this big number here in the calculator. Our upper bound, we're going to type out negative 1.5 because that is our z-score for the figure of 68.45. Now if we're using z-scores, again, the mean is always going to be 0 and the standard deviations are always going to be 1 with using the z-score. So once you type in that negative 1.5, all you need to do is click OK. In which case you should get 0.0668. So the first way we did it, we did do normal CDF, and I'm going to say negative infinity to negative 1.5. We had 0 as our mean, standard deviation was 1. When you do this, you can write this out, normal CDF, and put this in there, but you have to label the numbers. So lower bound is negative infinity, upper bound was our negative 1.5, our mean was 0, and our standard deviation was 1. And with that, we got 0.0668, right? Which is 6.68%. So 6.68% of the runs will give the Delorean a speed less than 68.45 miles per hour. 6 by 6 there, looks kind of bad. Alright. Now there is another way we can go about doing this as well. If you do not have a calculator like that, if you have Microsoft Excel or if you want to use Google Sheets, you can do either one. I've got my Excel right here already pulled up, but I've already tested it in Google Sheets and it does work as well. So you can go here and just in a cell here, just hit the enter, and then type out norm. It should give you a list there. And you want it to be the norm distribution, so norm.dist. Okay? Normal distribution. Now, within the normal distribution, it tells you what you need to put there. You can kind of see it. X is the actual value you want. that you're looking for. So in this case, our z-score. So our z-score was negative 1.5, comma, and then we've got our mean, which our mean in this case was 80. Oh no, sorry, our mean in this case, we use z-scores, is 0. Our standard deviation is 1. And then where it says cumulative, in this one, you want to type out true, okay? So true, it gives you true or false, but you want to type out true, or select true. Now close parentheses and enter, and look at that, it gives us 0.0668, the same setup right there, okay? So with what we've gone over so far with there, that is the 68, 95, 99.7 rule in a nutshell, okay? Again, I'll write that up here. There's 68, 95, 99.7. Those three numbers you will get tired of hearing in statistics. All right, let's see what the next question is here real quick. So, what percentage of the runs will give the Delorean a speed between 70 and 95 miles per hour? Show your work. Well, we already know what our mean is, what our standard deviation is, and what we need to do with it, right? But we need to draw all these fun things to get this labeled out. So, we know that we need to get between 70 and 95, okay? So let's go ahead and put this in here then. Make sure I'm on the right problem. I didn't skip one, did I? Did I skip 6? I did skip it. I went so dang fast like it didn't look right. Then I went to 5. Okay, so let's do number 6. What percentage of the runs will give the Delorean a speed greater than 85? So let's get my draw. Okay. I'm going to say our mean is right here at 80. And we had, remember, normal, 80. And our standard deviation was 7.7. Now it's wanting us to go 85. So 85, I'll just draw, let's say, a line right here. Say it's 85. And it says greater than. So it wants, best thing to do is shade under the curve where you want to find. So if we know that, now what we need to do is find our z-score. So to find our z-score, we take our value minus the mean over the standard deviation. So we know we have 85 minus 80 over standard deviation of 7.7. Now hopefully this makes sense too. Of course we should get a positive number, right? Because 85 is greater than the mean, so we should have a z-score that is positive. So that's one way to make sure you're lining up the numbers correctly. Because 85 minus 80 is still going to give us a positive number, so we know we're doing it right. If you mistakenly put the 80 first and you got a negative value, that should be a big red flag that shouldn't work out. We should have a positive z-score. Alright, so anyway, that should give us, let's just put that in the calculator and see what z-score gives us. So 85, minus, oh my gosh, let's do it again. Voodoo pen, there we go. 85 minus 80 divided by 7.7. Okay, so we should get 0.649, so I would say 0.65. So 0.65. So that's our z-score. So I'm just going to write it right here again. Z is 0.65. And we're wanting to find everything greater than that. Well, now we can go ahead and do our normal CDF if you have that. Normal CDF, in which case we'll go with negative infinity. Our z-score value is 0.65. And we have our mean is 0 and our standard deviation is 1. So again, this is our lower bound, upper bound, our mean, and our standard deviation. So let's see what that gives us. So I can go here, I'm going to go menu 6, 5, 2. Negative infinity, upper bound is 0.65. 0 and 1 are standard deviation. Okay. So I'm going to say 74.22 or 0.7422. We'll go with that. 0.7422. I recommend at least going up to 4 decimal places when dealing with statistics. When you have big numbers like that, at least 4 to give you a justifiable means for rounding. Now, with that again, remember we went from negative infinity or lower bound to upper bound of 0.65. So what I just found out was the percentage here. I found everything in green. Did we need that? No, we wanted greater than. So to find that, we're going to simply take, to find our red value, we're going to need to take 1 minus 0.7422. Now I'm saying 1 minus that because 1 is equivalent to 100%, right? And right here, if you're going to put this in percentage, that'd be 74.22%. 74.22%. So to find this, we're taking 1 minus 0.7422. So here I'm going to say 1 minus, and then I'll do second answer. And we should get 25.78. Well, let me do it, just make sure I get off. 1 minus 0.7422, just so we're using the answers we got. Alright, so 0.2578. So 0.2578, which is equivalent to 25.78%. So the percentage of runs that will give the Delorean speed greater than 85 miles per hour is 25.78%. Okay? All right, so now there is another way you can do this. Before I tell you that, again, on the spreadsheet, if you're using the spreadsheet version, equals norm distribution.dist. Oh goodness. Maybe if I selected this hitting enter, apparently I gotta click it. Okay. So our X value was, what was it again? 0.65. So 0.65. Our mean is 0. Standard deviation is 1. And we want that to be true. So we still got the 74.22. And then you would take 1 minus that and still get the same answer. There is another way to do this. because these calculators are fancy, and even the spreadsheet should be able to do this as well, you don't technically need to find the z-score when dealing with these for percentage-wise, because with this, we said we wanted our lower bound to be 85 in this case, right? And everything above that. If that is the case, you could say normal CDF, your lower bound is, well, we're going to do this two ways. Two ways to do this. I'm going to do it first with the z-scores and then with the actual numbers. So if you want to do this to find a greater than to start out with, you can simply say, with these calculators that we have, you would say that you have your lower bound is 0.65, lower bound. Your upper bound, you don't have to put infinity, you should put a really big number. Okay, so I'll just put like 4 nines. Okay, so that's your upper bound. We're still using z-scores, so we'll do 0 for our mean and 1 for our standard deviation. If we do that in the calculator, menu 652. So for our lower bound, we'll say 0.65. Upper bound, we'll say 4 nines. 0, 1. Oh my goodness, look at that. It gave us the exact number we just calculated. 25.78. 25.78. And half the work. There's an even quicker way without finding the z-score is what I want to talk about. So that's if you still find the z-score and want to verify it that way. Another way you can do this is, let me get a good color here, I'll go purple. No, purple's good. So normal CDF, because these calculators are so smart, you can say your lower bound is 85, the actual figure we're looking for. Your upper bound, you can simply say another big number, bunch of nines. So lower bound, upper bound. Your mean, now your mean in this case is 80, right? If you're going to use the actual figure of 85, 80 is your mean. And your standard deviation, which we wrote up there, is 7.7. So this is your mean and your standard deviation. Even if you'll use those numbers, you have to label what your lower bound, upper bound, mean, and standard deviation are. So let's go back to the calculator. Let's say menu 652. Our lower bound was 85, a big number. Upper bound, 80 was our mean, and standard deviation was 7.7. Look at that. Even better. 25.8. 25.8% is what we got on that. Same thing. Again, the number isn't always got to be exactly 100% to the decimal correct. As long as you do it in the correct process and label things properly, that is how you do it. Now let's make sure that this works out in the spreadsheet as well, same way, which it should. So if we were to do this and say equals norm distribution, we click that. And then we said our x value was 85, the mean is 80, standard deviation is 7.7, and we want it to be true. Oh, look at that. The trick is with these is you can't set your lower bound and upper bound. So with this in the spreadsheet, it's going to give you from 85 to negative infinity. You couldn't adjust it to where your upper and lower bound were. So Again, you can still use the actual numbers, but it has to be done, or you have to remember to subtract that from 1 if you're getting greater than that value. Hopefully that makes sense. Again, that just gave you like the green shading here value here, even if you use the real numbers. Fortunately, with the TI Inspire, and I believe the 84s you can, I'm not 100% sure, but I think, actually no, I'll take that back. I believe the 84s are stuck with, you have to use z-scores, and they only give you from your value to negative infinity. But the fortunate thing with the TI Inspire is that you can adjust your lower bound and upper bound to what you want it to be to get an even more accurate percentage rate. Or not rate, but accurate percentage. Okay, so now we can go through these pretty quick, right? Because now you've got what's the percentage that runs the Delorean will speed from 70 to 95 to show the work. So with this, here we know in 87.7, 80, and we're wanting to know from 70 to 95. Well, if we already understand the calculator and can do this, you don't need to calculate z-scores. Or you could, but the easiest way to do this is simply go normal CDF, lower bound is 70, upper bound is 95, our mean is 80, and standard deviation is 7.7. So lower bound, upper bound, mean, and standard deviation. What does that give us? So menu 652. Lower bound was, I'm forgetting what it was, 65? Oh, 70. 70. 95 is upper bound. 80. And 7.7 is standard deviation. So we should get 87.72. And that is the answer. 87.72%. Now, you could have done this as well the other way. Now, if you have to use the spreadsheet to do this, again, you've got to do two different things here. You would need to set this up to initially calculate. So let me do this. The blue that I just did gives you this value right here. Boom. Now if you're going to use the spreadsheet, you need to go from 95 0. So with that, easiest way to do is to find your z-scores for these guys. So z is 95 minus 80 over 7.7. Minus 80. Oh my goodness, what is it doing? $95 minus 80 over 7.7. So 1.95. So like a 1.95 for that z-score. And a z-score for 70 is 70, which hopefully you see that should be negative because it's below the mean. 7.7. So 70 minus 80 divided by 7.7. So negative, we'll say negative 1.3. So now, if you're just doing this way, the easiest thing to do now is, since we have, well, since I got red, we'll do this first one here. So we'll do, or 95. So normal CDF from negative infinity 1.9501. That's lower bound, upper bound, mean, and standard deviation. So that menu 652. So that 1.95 is our upper bound, and 0 and 1. So it should get 9744. So 0.9744. 0.9744. Now that's from 95 all the way to negative infinity. Now we need to find from normal CDF from negative infinity to negative 1.3 to 0, 1. And that should give me 652. So negative infinity to negative 1.3, 0 and 1. So 0.0968. 0.0968. 0.0968. So now that gives me from here to infinity. But we're trying to find that blue. So to get that blue, we would need to then take 0.9744 minus 0.0968. And what does that give me? So 0.9744 minus 0.0968, and that gives me 8776. Oh my goodness, 8776, which is 87.76%. So these guys are exactly the same, right? A lot more work, though, unfortunately, to find z-scores. You're not always going to be able to just do this normal CDF stuff. But if it asks just for that percentage, you can do that. So again, don't forget, though, that this z-score is 1.95, this is 0, and this is negative 1.3. Okay? That is why that played out. These are the z-scores. Alright. Let's see. We got time to do one more, I believe. Okay, so this says Marty wants his last run to be in the top 15% of all possible speeds. What speed does he need to achieve to be in the top 15%? Well, let's think about this. Top 15%. So we're going to draw it out. Alright, so he wants to be in the top 15%. So in other words, he wants this percentage, the area under the curve, the top, right? He wants that to be the top 15%. Or, shall we say, 0.15, right? Which is 15%. But we don't know what that number is. But we do know what? We know it's a norm. Mean is 80, and our standard deviation is 7.7. So we need to label our mean. Okay. Now to do this, let's go ahead and see what value we need to get here, right? So let's use a calculator set for inverse norm. So for the inverse norm, we're going to simply say inverse norm. And then the calculator on the TI Inspire, menu 652. Oh, I'm sorry. Just getting excited there. Menu 65, inverse norm, number 3. So now I want to know the area. Well, we said the area for this setup was 0.15, right? Well, but what's the area below to the left of that, right? Because this is going to give us inverse norm all the way up to that value. So let's say our area is 0.15, but we want to know overall. Area is going to be 1 minus 0.15, which equals 0.85. So we're going to put 0.85. Our mean was 80. Standard deviation was 7.7. In which case we should get right around 87.98. So we had 0.85 as our area. Our mean was 80. Our standard deviation was 7.7. And that gave us, what was that number again? 87.98. So this value right here is 87.98. So let's see how it works out on the spreadsheet. Alright, so for the spreadsheet, let's go into the D column here. We'll say equals, and this I know is norm, but it's going to be .inv for inverse. So it wants to do the probability. So I'm going to say 0.85. Our mean was 80 and our standard deviation was 7.7. That gave us the value of 87.98. Same thing. Same thing. So it does work the same way in the spreadsheet as well. You don't even need a fancy calculator as long as you have Google Sheets or Microsoft Excel. Either one of those will work. Alright guys, that takes care of normal distribution. Hope you enjoyed. I know it was a long video, there's a lot to cover. So hopefully this all makes sense, and I'll see you next time.